Hello everyone, welcome back to my channel, and in the words of Hagrid, I've got a real treat for you today. So what we're going to be looking at is finding the general solution to the equation for forced damped simple harmonic motion. So the equation that we're finding the general solution to is y double dot, that's just d2y by dx squared, so second differential of displacement, plus 2 gamma y dot, where that's a resistive force, so that's the dampening part of the equation. That's proportional to the velocity. So if you had a resistive force proportional to the velocity, you'd have something like k y dot, but in this case, k is equal to 2 gamma, okay? Don't ask me why, it just is. And we're going to deal with that. Right. Okay. Plus, why am I writing a gamma? Omega naught squared y. That's the part that completes the SHM. So, if you remember from the definition of SHM, y double dot must equal minus omega naught squared y. So, yeah, that's the definition of SHM, where omega naught is the natural frequency of the oscillations. Okay? So then that will equal f cos omega t. And that's the forced part of the equation. So when we find our general solution, there'll be a transient part, as in a part with e to the minus something t, which will die away as time goes on. And then there'll be a steady state part, which is caused by this part here, which will gradually become the dominant. So you'll have something like this, and then it will all do something here. And it is very strange in the middle, and then it will go to something that's what we have here, okay? And that will gradually become the dominant part, the steady state part. So we have a transient and a steady state part. Anyway, let's get to solving this. So step one, we're going to solve the auxiliary equation. So the auxiliary equation, AE, is going to be lambda squared plus 2 gamma lambda plus omega naught squared equals 0. Now, if we solve this with our quadratic equation, we get lambda equals negative b, so 2 gamma, negative 2 gamma, plus minus the square root of b squared, so 4 gamma squared, minus 4ac, minus 4 omega naught squared. Oh, look, we can take out a factor of 4, which will then turn to a factor of 2 outside the square root. All over 2a, which is just 2. I'm going to cancel all the 2's in this equation, so I get minus gamma plus minus root minus 1 square root omega naught squared minus gamma squared. Okay, so all I've done is I've taken out a factor of minus 1 in here, and I've also taken out that factor of 4 and cancelled it. Quite simple, really. Okay, and now I'm just going to write my next step. Okay, and so my solution to my auxiliary equation is minus gamma plus or minus I square root omega naught squared minus gamma squared. Now, this will give my my transient part will look something like this, because this is m plus or minus ni. We're going to have e to the minus mt, let's call it alpha, alpha cos nt plus beta sine nt. That's going to be my my transient part of my equation. So now writing that out as with this stuff here, I'm going to write that as, just get ready, okay, the complementary function, this is called, is going to be y equals e to the minus gamma t times, let's use some cool square brackets, a cos square root omega naught squared minus gamma squared t plus b sine square root omega naught squared minus gamma squared. I'm going to have to write very small for this because this is going to get very large later. T. Right, now what we have to do to deal with this part here, we have to use something called a particular integral. And because we've got something in terms of causes, we're going to have a particular integral that looks something like y equals alpha cos omega t plus beta sine omega t. I've used omega here because we have omega up here, okay? Because we're just trying to find f. Because remember, when we add sinusoidal waves together, you can add them together. That's the point. Okay, so then we find y dot, which is going to be alpha minus alpha omega cos, not cos, sine omega t plus beta omega, not gamma, beta omega sine omega t, not sine, cos, y double dot is going to be minus alpha omega squared cos omega t, and we get minus beta omega squared sine omega t. Okay? Now what we're going to do is we're going to substitute these in where we have y dot, and y in our original equation. We're going to substitute these guys in, okay? But what I'm going to do, just to save time, is I'm going to piece them together in terms of the sine omega t and the cos omega t parts. So, therefore, we have minus beta omega squared minus 2 gamma alpha omega. So this is the sine omega t part. So we got minus beta here. The minus 2 gamma alpha comes from this part. And then we're going to get plus beta omega naught squared, I think. Are we going to get that? Yes, we are. Okay. Sine omega t, that was quite large. And then now we're going to get the cos omega t part. So we're going to get minus, plus, brackets, minus alpha omega squared plus 2 gamma, just 2 gamma? 2 gamma beta omega plus alpha omega naught squared plus alpha omega naught squared cos omega t. Right, now we need to equate coefficients because this is going to be equal to f cos omega t. Okay? And what we need to remember here is we are trying to find alpha and beta. Okay? So, we can instantly see there are no sine omega t's on the right-hand side. So we got minus beta omega squared minus 2 gamma alpha omega plus beta omega naught squared is going to be equal to 0. Let's do some rearranging and take some factors out. So we can have beta times omega naught squared minus omega squared is equal to 2 gamma alpha omega. I think, is that right? 2 gamma alpha omega, yeah. And therefore beta is alpha, I'm just going to take this out to the right, times, let's use some cool square brackets, 2 gamma omega over omega naught squared minus omega squared, close brackets. That's what beta is. Now let's do some finding of alpha. So this cos part is all going to be equal to f. Okay, so I'm going to write that down here. So we have that minus alpha omega squared, minus alpha omega squared plus 2 gamma beta omega plus 2 gamma beta omega, not alpha, omega, not gamma, plus alpha omega naught squared plus alpha omega naught squared is equal to f. Okay? Now we've just got to remember that this beta here we can substitute from what we just learnt. So we're going to get, oh look, we're going to have some squared terms in there. That's very nice. Minus alpha omega squared plus 2 gamma omega, I think that's going to be squared, alpha over omega naught squared minus omega squared plus alpha omega naught squared plus f, not plus f, equals f. Silly mistakes in the exam, eh? Okay, so, did I just do something very wrong? I think I may have just 2 gamma beta omega, 2 gamma. No. That's fine. Okay, so we take out a factor of alpha, and that's going to be omega naught squared minus omega squared. Oh, we can take out a factor there. That's going to be really cool. So let's put that in some big square brackets. Plus 4 gamma squared omega squared over, see, this is where it gets pretty wild, squared minus omega squared, all squared. Isn't that something that's just a bit no, we don't have the double squared on the bottom. Yep, no, that's what we have. Let's do some square brackets, because otherwise this is going to get very complicated. F. Right, and we want to find alpha, so alpha is simply equal to f omega naught squared minus omega squared over omega naught squared minus omega squared plus 4 gamma squared omega squared. That is quite simply what alpha is. So we have alpha and beta. That is rather interesting. And also, if you look here, we're going to be able to cancel this bit for the beta part. Okay, let's have a bit of a look at our particular integral. So I'm just going to redefine beta just for the sake of sanity. Beta is going to be equal to 2 gamma omega over omega naught squared minus omega squared times brackets omega naught squared minus omega squared. You can see they're going to cancel. This is great. F divided by omega naught squared minus omega squared squared plus 4 gamma squared omega squared. Use the same brackets you started with. Anyway, big cancel here. Let's do that. Wham! Wham! Oh, that was satisfying, wasn't it? Okay. And that is going to be equal to 2 gamma omega. So F times 2... let's write it a bit further to the right. F 2 gamma omega over omega naught squared minus omega squared plus 4 gamma squared omega squared. That is what beta is. So my general solution is going to be very long. It's going to be very, very long. Okay? So my general solution is going to be y equals the transient part, which was e to the minus gamma t times, I'm going to have to write this on many rows, times a cos square root omega naught squared minus gamma squared t plus b sine square root omega naught squared minus gamma squared t. So that's my transient part. Plus, let's do some alphas and betas. So alpha was, what was alpha? Alpha was f times no. Yeah, plus f omega naught squared minus omega squared over, I think it was, what was alpha? Yeah. Omega naught squared minus omega squared plus 4 gamma squared omega squared times cos omega t plus the beta bit, which was f2 gamma omega, was it f2 gamma omega? I want to check. Yeah. Over omega naught squared minus omega squared plus 4 gamma squared omega squared times sine omega t. So that's our general solution, but really that's quite dissatisfying. What we want to do is we want to add these two together. We want a big old plus sign, so let's do that here. Big plus. That's not very neat, but you get the idea. Okay, so we're going to do that. So our new y is going to be equal to, for our general solution, mark 2. Okay, so we're going to have the transient part. I'm just going to write transient. And then I'm going to start doing some rearranging. So in terms of the bit inside, we're going to just treat it in terms of sine waves. So in terms of the sine, it's going to be sine omega t plus epsilon, because that just means it's been translated a little. Okay, what we're going to really deal with is this bit here, the r value, what it's been multiplied by. Okay, so it's amplitude. That's what we're going to be dealing with. So transient plus, okay, so we're going to do a bit of Pythagoras. Now they've got the same denominator, so that's very useful. So let's do a bit of that. So we can have f squared we can take out a factor of f squared. F squared omega naught squared minus omega squared squared plus f squared 4 gamma squared omega squared. Now I can see some of you will have spotted this already, but something is going to cancel and it's going to be glorious. Omega naught squared minus omega squared squared plus 4 gamma squared omega squared. And is that going to be squared? Yeah, that's going to be, I think that's going to be squared. Squared square rooted times sine omega t. Let's do some ditto marks. Do-do. And let's start dealing with this. So the f can come out instantly. And so we're going to have an f out here. Then we're going to have the square root of omega naught squared minus omega squared squared plus 4 gamma squared omega squared over, here's the key bit, omega naught squared minus omega squared squared plus 4 gamma squared omega squared. See, this is just the top squared. So what we're going to do is we're going to do some more ditto marks. Plus f over the square root of omega naught squared minus omega squared squared plus 4 gamma squared omega squared. Okay? So that's a very nice result. So this is my steady state part. Now let's try finding some facts. So when are we going to find resonance? Well, that's when we have the maximum steady sine omega t, the maximum steady state amplitude, which is the f over this bit here. Okay? So what we're going to do is we're going to differentiate with respect to omega what is in here. Okay? So d by d omega of omega naught squared minus omega squared squared plus 4 gamma squared omega squared by d omega must equal 0 at a maximum or minimum. Stationary point, gradient equals 0. Okay? Therefore, 2 omega naught squared minus omega squared times, you're happy with a dot, minus 2 plus 8 gamma squared omega must equal 0. Now let's do some rearranging. So we're going to take out a factor of 4. That should have a gamma there. We're going to take out a factor of 4 gamma. So we're going to get 4 gamma times 2 gamma squared minus omega naught squared minus omega squared equals 0. Have I got that right? Yes, I have. So, either omega equals 0, which is not the case at resonance, because if omega was 0, it wouldn't be moving. Or 2 gamma squared minus omega naught squared plus omega squared would equal 0. Now let's do some rearranging. So therefore, Therefore, omega resonance is equal to the square root of, omega must be it doesn't really matter if it's positive or negative, I don't think. So omega must be equal to the square root of omega naught squared minus 2 gamma squared. So that is a beautiful result that we have just obtained from all of this algebra from this original equation at the top. So the equation for the resonant frequency, so omega resonance, is equal to the square root of omega naught squared minus 2 gamma squared. Thank you for attending this video. I really hope you enjoyed that as much as I did. I'm sorry I haven't posted a lot of videos recently. I've been quite busy, but I will try and post every time I have something I think is really brilliant, and I thought this was, so I had to share it. So thank you very much for attending this video, and I look forward to seeing you all next time.